Welcome to yet a very wonderful class, and today we want to talk about linear expansivity, and that is the topic, and this is a subtopic under heat energy. And before we continue, I want to just give a little illustration of what is linear expansivity. When we talk about linear expansivity, we use this symbol to represent linear expansivity, and this linear expansivity is defined as increase in length per unit length per degree rise in temperature. That means a particular increase in a length due to temperature increase. For example, if a body is of this length, or let's say a metal rod of this length, and then when it is heated, what happens? It increases a little. To this small extension increases a little, and each method increases based on its nature, because there are some metals that increase more than some other metals based on the nature of the metal. So that nature of metal is called coefficient of expansion, and which is given as this. Now, this coefficient of expansion is given as change in length, that is L2 minus L1, all over L1 times change in temperature. What this means is that if the original length was 10, let's say this is 10 cm before heating, after heating, we now realize that it has reached 12 cm. You now realize that the little increment in the length is just 2 cm. Now, in this question, we are going to use this equation to further buttress the point we mean when we talk about expansivity. Now, having known this, this is linear expansivity. This is the second length when it was heated. This is L1 when it was not heated, and this is change in temperature. That means between the time it is heated and when it is not heated. And remember, before it is heated, there must be a temperature of a given metal. Do you understand? So we are going to look at the problem on the board. Now, he said that an iron rod is 1.58 meter long at 0 degrees Celsius. What must be the length of the brass rod at 0 degrees Celsius if the difference between the length of the two rods is to remain the same at all temperatures? Then the coefficient of expansion for iron is 1.2 times 10 raised to the power minus 5 per kilogram per Kelvin. This Kelvin is representing the temperature measured in Kelvin. And that linear expansivity for brass is 1.9 times 10 raised to the power minus 5 per Kelvin. Also, in this case now, what we are going to do is first, because there are two rods here. The first one is for brass, and this one is for iron. So what I'm going to say now, he said that an iron rod is 1.8. That means the original length for iron, okay? Original length for iron is given as 1.58 meters. Then, and the temperature, I'm going to call that temperature θ1 is 0 degrees Celsius. So θ2 is unknown, all right? So that when we talk about change in temperature, we mean θ2 minus θ1. θ2 is the temperature when it is heated. θ1 is the temperature when it was not heated. So when you subtract their values, you find the change in temperature between when it is heated and when it is not heated. Therefore, but they did not give me another temperature. So I am going to keep it this way. I'm going to say that instead of writing θ1, θ2, I'm going to bring the two of them as change in temperature, which is unknown. I don't know the change in temperature, but we have to find out later. Now, they say that, and this is for iron, okay? This is for iron. And also remember that L2 for iron, remember, I'm using L2 for iron. That means the new length of iron, when it is heated, it is still unknown. But then something I want you to know is that change in length is something as L2 minus L1, all right? So like I also said, L2 is the temperature when it is heated, the new temperature after heating, and L1 is the temperature before the heat is applied. All right. So if I look at this very well, I realize that linear expansivity of iron is equal to change in length all over original length of the iron times change in temperature. This is it. Because for the iron, we have this, and which I'm going to replace for this. We have 1.2 times 10 raised to the power minus 5 is equal to Change in length. I don't know change in length, so I'm going to put the change in length all over. Original length of the iron, that is the length before the heating is applied, is 1.58. I'm going to put 1.58 times change in temperature for iron. I still don't know, so I'm going to keep it as change in temperature. So why am I choosing this change in L over L2 minus L1? Is because I was not given the L2, I was only given L1. So that is why I choose this one over this, because this thing is the same thing as saying change in length all over L1 times change in temperature. Sometimes it can also be written as this, L2 minus L1 all over L1 times theta 2 minus theta 1. It can also be written like this. Depends on the nature of the question. So this is how I'm going to keep it for now. Now I'm going to go back to the illustration for that of iron. He now said, he said, what must be length of a brass rod at this if the difference between the length of the two rods is the same? That means, look at this word. If the difference between the length of the two rods, of the two rods is to remain the same at that point. Now, what that thing is saying is, look at this. You see, when we say change in temperature, change in length for iron is equal to change in length for brass. So that means this one is same thing for this. So what is the change in length for brass? They did not give me the initial length of brass, and that is what I'm looking for. So let me put something here. So length of brass is equal to, I don't know, that is what I'm looking for. All right. So but then linear expansivity of brass is equal to change in length for brass all over length of brass times change in temperature of brass. Okay, because this one is change in temperature for iron. Now I'm going to put the values for this one for that of brass, because we are looking at the two metals. So this is going to be 1.9 times 10 raised to the power minus 5 is equal to change in length for brass all over length of brass times change in temperature for brass. Now, something you should know is that change in length of iron and change in length of brass are the same thing. And I made change in length of the iron the subject formula. So it says that change in length of iron is equal to this times this. And that is how I got this whole thing here. Then change in length for the brass is same thing as this times this. And that is how I have here. But since they say that difference in length of the two rods are the same, therefore change in length of iron is equal to change in length of brass. So I'm going to say that this is equal to this. I'll have 1.2 times 10 raised to the power minus 5 times 1.58 times change in temperature for iron is equal to 1.9 times 10 raised to the power minus 5 times length of the brass times change in temperature of the brass. Now, one thing you must know is that 10 raised to the power 5 will cancel 10 raised to the power 5, right? Now, if you check very well, they say that that of the rod is at 0 degrees Celsius and that of the brass is also at 0 degrees Celsius. That means their change in temperature is the same thing. Therefore, this will also cancel this because they are the same thing. So I have 1.2 times 1.58 is equal to 1.9 times LB. So what is LB? This LB is representing the length, the original length of brass before the heating. Yes, before the heating. Therefore, I'm going to say that LB is equal to 1.2 times 10 raised times 2, 1.2 times 1.58 all over 1.9. And the answer is, so the answer is 1.896 all over 1.9. So if you check very well, the length of brass is approximately 1, because this divided by 1.9 is going to give me 0.998, which is approximately 1 meter. So that is the length of the brass at that point. Thank you, but please don't forget to share, like and comment.